Yeah, welcome back. Now we will discuss about logical inference. In this entire chapter, we use the complete concept of mathematical reasoning, what we have discussed there. In order to understand first logical inference, first you need to understand about premise and argument. What is a premise? It is a propositional statement which is used to derive the conclusion. Means, for example, yesterday we have seen the entire problem, right? For example, to make understand of premise, I am explaining this one. Yeah. For example, let this be the question of yesterday's. Then, if this is the complete problem, here individually parts by parts we made, right, to solve. Those parts are nothing but we say premises. Using all those premises, we can find complete solution. That is what premise. And what is the argument? Sequence of premises with conclusion. Means those individual parts, nothing but premises, and the resultant means the result table of this, I mean the truth values, those together is known as an argument. Now what actually is the definition of logical inference? Logical inference is nothing but deriving the solution using the evidences or premises. Another name of premise is nothing but evidences, we can say. But what actually the logical inference want to make understand is, if conjunction of premises, then conclusion is a tautology. Nothing but the premises are there, right? We will do conjunction for them. Means conjunction is nothing but and. All the premises we separate using this and then conclusion is said to be tautology. Let us consider an example. Let us take P implication Q, P, Q, P. And how to represent the premises in this? Let me consider an example here. This is a complete example. P implication Q, if this is true and if this is true and this is true, then this will become true. This is what I am trying to explain now. First we will do individually. First the truth values for PQ. True, 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 false, false, true, false, false. And now this is one of the premises. P implication Q. Already we know this one, so I am not going to explain. And here again no need to write P. Here for showing that is a premise I have written. Now P implication Q and we need to do conjunction of premises. This and this. What will get? P implication Q and P we are doing now. Nothing but conjunction of the two premises. True and true, true. True and false, false. False, false. Implication, then conclusion. Nothing but it implies to Q. Let it be X. X implies Q. If it is a tautology, then this is an example of the logical inference. What is X implication Q? True, true implies true, true. False, false, true. False, true, true, false, false, true. What we have got? Tautology. Since all the truth values are true, then what we say is P implication Q and P are premises. And what is the argument? This complete thing is said to be argument because premises along with the conclusion is said to be argument. This is what the actually logical inference. But before going to deeper into the topic, logics are classified into two types: propositional logic and predicate logic. Wait, I will write here. Propositional logics. Propositional logic, predicate logic. What is the difference? Propositions are nothing but simple statements which we worked till now, and we will work further for showing the inference rules. Then comes predicate logic. What actually predicate is used? Predicate logic is used for quantifiers, nothing but for quantities discrimination, nothing but all, some. In such cases we use the predicate logic because we can't describe exact number like that. For example, I want to drink some water. Some. All. All means all students have qualified in the examination. That is an example. Those will come under predicate logic. Propositional logic are nothing but, since now we discussed and now still we work on it. Now we will discuss the inference rules. Yeah, now coming to inference rules. First we will discuss modus ponens rule, and for every rule I will also derive how we have got it. Now what actually modus ponens rule states is, if P implication Q is true and P is true, then Q is also true. This is what modus ponens rule states, and this one we can write in form of our statements. Nothing but conjunction of premises P implication Q and P. This entire, if this is true, then Q is also true. This is means for this one we need to get tautology. Now we will draw the truth table for it, for derivation. Truth table. There are only two statements, PQ, P implication Q. Let it be X, X and P. Let it be Y, Y implication Q. Y implication Q, if we get tautology, then else modus ponens rule will be verified. Let us see. True, 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 false, false, true, false, false. Now coming to P implication Q. True, false, true, true. X and P. X is nothing but this one. P implication Q. And P. True and true, true. False and true, false. True and false, false. True and false, false. This is Y. Now what we need to do? Y implication Q. Nothing but this one implication Q. True implies true, true. False, false, true. False, true, true. False, false, true. Yeah, now if you see, we got this, all truth values are true. So this becomes the tautology. Hence modus ponens rule will be verified. Now coming to modus tollens. In modus tollens, if P implication Q is true and negation Q is true, then negation P has to be true. This one how can we write in form of symbolic? P implication Q conjunction. Yeah, remember this complete one is called argument, and above the line nothing but these two are said to be premises. P implication Q and negation Q, implication negation P. If this complete thing becomes tautology, then modus tollens rule will be verified. Let us see by truth table. Okay, meanwhile you write modus ponens. P Q, P implication Q, let it be in X, X and negation Q. Yeah, since negation Q and negation P both we are using, we also need to find negation P and negation Q. So give some space. P, Q, negation P, negation Q. X and negation Q, let it be Y, Y implication negation P. If these truth values are all true, nothing but tautology, then modus tollens will be verified. True, 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 false, false, true, false, false. Negation P first. False, false, true, true. Negation Q. False, true, false, true. First what we need to do? P implication Q. Nothing but true, false, true, true. And it is stored in X. X and negation Q. True and false, 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 false. This becomes true. This completing is stored in Y. Y implication negation P. False, false, true. False, false, true. False, true, true. True, true, true. Yeah, now all the truth values are true. Nothing but this symbolic form, this statement is a tautology. Means modus tollens is verified. With these two rules we have completed. Now remaining rules I will explain. Now I am rubbing modus tollens. Next, coming to transitive rule or hypothetical syllogism. Third one, transitive rule. Transitive rule. This is also known as hypothetical syllogism. Hypothetical syllogism. Yeah. Now, by name itself you can understand transitive relation we will get. If you are aware of sets and relations, in relations I hope you know transitive relations. In a similar way here transitive rule. If P implication Q true and Q implication R true, then obviously P implication R must be true. This is what transitive rule states. And for this, in the same symbolic form you need to write and draw the truth table for derivation. First what? Write in symbolic form P implication Q and Q implication R. This one implication P implication R should be tautology, then this rule will be verified. First here the truth table will be big. So first there are three statements, nothing but 8 values you need to take and you should evaluate. P, Q, R, P implication Q, Q implication R, let it be X, let it be Y. I hope you have noted this one. I am rubbing because we need to draw big truth table for this. Yeah, now X and Y. Another thing is P implication R. Let it be Z. This X and Y implication Z we need to do. X and Y implication Z. Now coming to here. Write the 8 possibilities. Yeah, these are the 8 possibilities as I told yesterday to do in a simple form. You can write fastly. Now P implication Q. As you know already I am writing it faster. Yeah, this is P implication Q. Now do Q implication R. This is Q implication R. And of these both. True and true. True, false, 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 true, false, true, true. And now P implication R. P and R. True, 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 false, false, true, 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 false, false. Next false, true, true, false, false, true, false, true, true, false, false, true. Now what we need to do? X and Y implication Z. True, true, true. Yeah, we got all truth values true, nothing but tautology. So transitive rule is also verified. Next we are going to see disjunctive syllogism. First make a note of it. Fourth one, disjunctive syllogism. Fourth one, disjunctive syllogism. Yeah, what actually is disjunctive syllogism is, if P or Q is true, listen, P or Q is true, negation Q is true, then P must be true. Sorry. I have written wrong. Disjunctive syllogism. P or Q true, negation P is true, then Q has to be true. First, actually, you need to understand what actually we are trying to explain here. P or Q, nothing but if P or Q we need to get true, any of these statements must be true. Here what he is saying, negation P is true, nothing but P is false here. Then if Q is true, then only we will get the P or Q is true, right? That is the reason Q is true here. That one we are going to prove using the truth table now. Truth table. Yeah, first this one in symbolic form you write P or Q and negation P implies Q. This is what the symbolic form. Now truth table. P, Q, negation P we are using, so keep that one. P or Q, let it be X. X and negation P, let it be Y. Y implication Q. If the truth values of this entire statement is true, nothing but tautology, then this rule will be verified. Disjunctive syllogism. First write the truth values: true, 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 false, false, true, false, false. Negation P, opposite of P, false, false, true, true. P or Q, true, 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 false. Now this is stored in X. X and the negation P, and false, false, true, false. And this completing B, Y, Y implication Q we need to find. False implies true, true, false, false, true, 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 false, false, true. Yes, we have proved it is tautology. So disjunctive syllogism is verified. Up to here you make a note of it. Yeah. Still now we have seen 4 rules. These are the remaining 3 rules. With this we complete the inference rules and we will start problems. First, conjunction. I mean the 5th one, conjunction rule. Conjunction is nothing but and. For that I am first taking the argument. These 2 are premises. If these both are true, the resultant conjunction is always true. If the both truth values are true, then only conjunction is true. This is what we have learnt in conjunction. In inference rule, that is called conjunction rule. If these both are true, obviously this will become true. You can also verify using the truth table, but these are not so much important. That's the reason I am not explaining with the truth table. If you want, you can verify it. This is the conjunction rule. Next, coming to addition rule. Addition rule means what? There is a doubt for you. As in the first video of the mathematical reasoning I have explained OR and AND differences by comparing it with logical gates. In logical gates, for AND we do like multiplication, for OR we do like addition. Here addition also same, that one only, nothing but addition we use OR. With OR we are going to use it. Nothing but if one of the statement is true, let it be P or Q, anything. then obviously what will happen? P or Q is always true. That only or logic states. If any one of the truth value is true, then obviously resultant is true. Here in premise you are having P is true. So in conclusion we get this one, P or Q is true. Similarly, instead of P, if you take Q also, no, not an issue. If Q is true also, same, this one only, P or Q is true. This is a complete argument, this is premise, this is conclusion. Next, simplification. Simplification, nothing but P and Q if we take. P and Q, this is only one premise we have taken. What we are saying, P and Q is true. When this one will become true as per our knowledge in AND logic? P and Q means P must be true, Q must be true. This is what we have learnt, right? But here when we are discussing in logical inference, that means inference rules, there should be only one conclusion, no many conclusions. So if P and Q is true, we can say this one, or else we can also write like this, P and Q true, and the conclusion Q true. Both are similar. This is known as simplification rule. With this we have completed the inference rules. Now to solve inference problems we need to know the difference between rule P and rule T. What are those? Rule P and rule T are used to solve the problems of the problems using the inference, means deriving conclusion using the inference rules. First, what is rule P? Still now we have read that what is a premise, right? So, rule P is nothing but introducing the premise. That's it. We will introduce the premise. Introduce the premise. What is rule T? Rule T is nothing but when we introduce the premise. And remember that while solving problems, every time first we introduce the premise, then only we start. And here we have introduced the premise. Then what we need to do? We can introduce another premise, or directly we can do rule T. What is rule T? Simplifying the premise based on the inference rules. Yes, simplify premise based on inference rules. That is the reason we have learned the inference rules now. Inference rules. Now we are going to see the problems. Yes, this is the problem which will be asked. Show that R or S follows logically using the premises. And they have given 1, 2, 3, 4 premises. From that we need to show that this statement is derived using these premises. How we need to do? Here, if it is asked normally, you use it to do like full truth table. It takes lengthy time if the statements keeps on increasing. So to reduce that, we use the inference rules and those all stuff. Now, for solving the problem, you need to make 4 columns. What are those? Step. Means which step? Step 1, 2, 3, 4, those all. Next, premise. Means what you are going to introduce or what we are going to get. And next coming to rule. Rule is nothing but, as I told, rule P, rule T. Rule P means nothing but introducing premise. Rule T nothing but using the inference rule to minimize the premise to get the final solution. Rule and justification means which rule are you using. If rule T means if inference rule, what kind of inference rule you are using to get the solution. Justification. Yeah. Now step 1. I am introducing the one more thing, you can introduce the premises in any order you want. For example, I won't take in the order, I will take randomly so that you will understand how to solve it. First take this one, COD implication NH. C or D implication NH by rule P, because you are just introducing the premise. That only you should write here, introducing the premise. Next, again you are introducing another premise, that is NH implication A and negation B. Yeah, now don't introduce the premise. If you observe this one, this is in the form of transitive rule. P implication Q and Q implication R. What can you write? P implication R. Nothing but C or D implication A and negation B. This is what rule T. What is the justification? Which rule you are using? Transitive rule. And simply don't write transitive rule. You need to write for which steps if you applied you got that one. Transitive rule for step 1 and 2. 1 and 2. Now another premise I am introducing. A and negation B implication RRS. A and negation B implication RRS. Again what rule it is? You are introducing, right? Rule P. See, in justification don't worry. When you write rule P always write introducing and premise you write. Next fifth one. Yeah, fifth one, now don't take that leftover premise. See whether you can simplify or not. Again by transitive rule, P implication Q, Q implication R, nothing but P implication R. What can you write? C or D implication R or S. Since you have used by rule T, which rule you have applied? Transitive rule. Transitive rule for what steps? Step 3 and 4. 3 and 4. Yeah. Now only one is left over, one premise. So introduce that one also. Step 6. Introducing C or D. Again rule P. Once I write here so that you won't get confusion. Introducing premise. Introducing premise. Yeah. Now there are no leftover premises, so now you need to get the final solution. Because he is saying that show that, he is not asking prove, means whether it is true or not. Means we will obviously get this one. So you need to get the answer in such a way. What you will do? P implication Q true, P true. Which rule it is? Modus ponens. Step 7. Directly we will get R or S. Therefore what you can say? R or S follows logically using the given premises. You need to write in therefore statement. R or S using rule T. Which rule? By modus ponens. Modus ponens. On which steps? 5 and 6. Yeah. This is what the solution you will solve using the inference rules. So, you only decide whether doing truth table for that much lengthy process. Here, those we have done because there are only 2, 3, nothing but PQ, PQR like that. Here if you see, A is there, B is there, C is there, D is there, R, S, NH, you won't do that much big, right? Anyone can't do because it takes more time. Means these inference rules makes us to save our time. That is the reason it is applied in artificial intelligence also, in knowledge representation of AI. Now another problem we will see. Yes. Similarly, this is another question. Show that R implication is using these are the premises. this TR premises is valid conclusion or not. Yeah, one more thing is valid is nothing but tautology. Not valid means it can be counterpositive or contingency. Now similarly draw the table. Serial number, premise, rule, justification. And before that, don't forget the implication rules. It is very much important to solve this problem. And what are the implication rules? P implication Q is nothing but negation P or Q. Negation of P implication Q is nothing but P and negation Q. These both rules are important to solve this problem, because every time we won't get simpler questions like we have solved the previous one. Now first I am going to introduce negation R or P. Negation R or P. Since this is rule P. And at second step, it is similar to which one? By law of implication, negation P or Q form, right? So what can we write this one as? R implication P based on law of implication. R implication P, rule T by law of implication. Law of implication. For which step we are doing? Step 1. Now introduce another premise. This is the premise we are going to introduce. P implication, Q implication S. Since we are introducing rule P, next, by seeing the step 2 and 3 transitive rule, P implication Q, Q implication R, then P implication R. Nothing but R implication of Q implication S. By rule T, here you need to write transitive rule. Transitive rule. And still we left over with this premise, but directly we can't take it because it is complex. We need to simplify. Now apply double negation for the step 4. Applying double negation. Rule T. Here transitive rule for step 2, 3. Here double negation. Double negation for step 4. Next, coming to 6th step, keep one negation outside only, and by seeing one negation, if you apply, it is similar to this one, nothing but P and negation Q, right? One negation is as this, and one more will be as P and negation Q. Q is this entire thing, Q implication S. Rule T, again law of implication, this is law of implication. Law of implication for step 5. Next, in the 7th step, again if you see, this is negation. Negation of P implication Q format. So you can write as P and negation Q. So first negation as this R and negation of P implication Q, nothing but P and negation Q. P is nothing but Q and negation S. Let me finish this one. Rule T. Again law of implication for step 6. Now in the 8th step, here we since we know commutative law, P and Q is nothing but Q and P itself, right? So we are just interchanging those. R and negation S and Q. There will be no change. Just you need to write commutative law. Rule T. Commutative law. Commutative law for step 7. Yeah. Now coming to 9th step. By associative property, we are doing for R and S, we are making one combination and Q separate. The reason why we are separating Q from this tree is we are left over with an premise only Q. So to get it simplified, I am separating the Q to single one. R and negation S and Q. Yeah. Here rule T by which law? Associative law. Associative law for step 8. You need to mention everywhere. In rule P I have ignored because you can write introducing a premise. Now rule 10. Yeah, this is in which format? Negation of negation of P and Q is nothing but what? Negation P or negation Q. This is which law? De Morgan's law. Negation of R and negation S or negation Q. Rule T by De Morgan's law. You need to remember all these rules, because if you see direct, you will say directly that there is no possibility and you will say that it is not valid, then that completely goes wrong. So every rule plays an important role in solving these inference problems. De Morgan's law for step 9. Yeah. Now the thing what you do is, now you introduce the premise Q. 11. Introducing the premise Q. So nothing but rule P. From this both you can say one thing. This is in the form of, let it be Q, let it be P. P or Q true, negation P true. This is which one? Disjunctive syllogism. Then Q has to be true. Nothing but, yeah, here you may say you can take this P and this Q. So by commutative law you need to reverse the step 10. Then this becomes P, this becomes Q. Then P or Q, and this is negation P, right? Here negation Q is there, here Q is there. Negation. So Q has to be true. Nothing but negation R. I am writing here. Negation R. I mean negation of R and negation S. Negation of R and S we will get in rule T by disjunctive syllogism. Still the solution is not completed. Disjunctive syllogism. For which steps? Those steps every time you need to mention. Step 10 and 11. Yeah. Now it is similar to which one? R and negation S. R and negation S is nothing but P implication Q. We can, I mean negation of P implication Q we will write. Then here one more negation is there. So negation of negation will become simply R implication S. That step I will write here. Hope everyone written. Now step 13. Yeah. Step 13. Now from this one what can you write? Negation of R and negation S you can write as negation of R implication S. R implication S. This is rule T by law of implication. Law of implication. On which step we have applied? on for step 12. Law of implication for step 12. But still our answer is not completed. Here double negation. By double negation it becomes R implication S and hence this becomes valid. Yeah. Negation 14th step. It becomes simply R implication S. Rule T by double negation concept. Double negation of step 13. Yeah, R implication is we need to prove, right? Show that R implication S using is valid conclusion or not. We have got R implication S. Therefore, the given statements and the premises. The given premises made us to obtain the solution. Hence, it is a valid conclusion. That's it. With this problem, we will end here. And next, we are going to begin predicate logics. Predicate logics and propositional logic differences. I will repeat again. First, make a note of it.